Um, Today demonstration, I just want to. This is my. You can see this is my SOA meter. This one is you can see the model, but the difference is that this one. Uh, let me pull it out. You see, it's a SOA product. This is the manual. So, so now the difference about this meter is this one is auto power off, which means that if you leave it on for a while without checking anything, it will, when you stay for like some minutes, it will automatically switch off to one. But this one, if you leave it on, it will stay on to off unless you off it by yourself. It doesn't have the auto switch off. But this one, even though the power button is on, with some minutes it will automatically switch off. So that is the difference. So, but I'm supposed to use this meter, but um I put it, yeah, the maximum AC input is 750, 750 volt AC, but the voltage rise to almost 800 to 900, so the meter still misbehaving, so it doesn't read accurately. So this one is a 700 volts maximum, so this one top it with 50 volts. So, but the DC is the same, 1000. So that's the difference. So what I want to demonstrate is you can measure uh, you can measure AC DC currents without using clamp meter. Assuming that you don't have a clamp meter, you can measure the current, AC current, with this multimeter. Assuming you have this multimeter, you can measure DC current draw and AC without using a clamp meter. Assuming you don't have a clamp meter. So what am I mean? So what I mean is let me use it out. So this is the stand. I can play the stand. And also let me bring my power source, my socket. So this is the 220. This is my AC induction motor. This is my AC induction motor. So this is my AC, about 300 watt, there about 400 watt AC motor. So let me put it at source, so you can see it's turning, running. So let me pull it off now. So what I want to demonstrate, okay, now in my channel, um, I teach a lot of things uh, because I'm informed with electrical and electronics. So not only about full generator, so I teach a lot of things. So now this is the meter now. As you can see, this range it is for AC. I mean DC. So now here is from AC down here. So when you want to measure high voltage, it's safer you put it at 700. In DC, when you want to measure high voltage DC, it's safer you put it at 1000. Okay, now you can see the point here. You can see this is the 20 amp, milliamp, common. This is the continuum, understand, like positive. Okay, now so some people don't know the slots here, what they define only just to measure the voltage. So, but this meter you can use it to measure DC current and AC current. So now this is for voltage. Okay, this is for voltage now. Okay, let's switch it. Okay, now let me check what is the voltage of this source. Let me on it now. Okay, I see very well flattened. Okay, okay, now you can see the voltage. So now this is for voltage. Okay, we want to check. I want to check what is the current this motor is consuming from the power source. So now, how do we do it? So now you have to switch here. You can see this 20 points dot. So that is for current. When you want to check current. So what the next thing you will do is you have to pull this off, this terminal off. Then connect one here. You can see this range from this 20 amp down here. See it. You can see the connection. Okay, now what you have to do is this is the terminal. This is the terminal. So now this is the terminal of the voltage of the motor, the electric motor. So now this is the two terminal. You can see, let me connect it on power source again so that you can see the motor is running fine. Okay, now we don't know the power consumption of this motor. We don't know the power consumption. Okay, now what? So now one of the terminal of this uh one of the terminal of the motor, we have to connect it to this terminal of meter. I have to connect it. Then put one terminal of the AC motor and one terminal of DC meter. I mean the micrometer. You can see 0.20 amp. So what the motor is consuming is 0.20 amp. Can you see? So what the motor is consuming is 0.20 amp. Let me test it again. You see 0.20 amp. So 0.20 amp is what the motor is consuming. 0.2. 0.2 is what the motor is consuming. So now we have to check for DC. We have to check for DC. Okay, like I said before, we have to let me pull. This is the AC motor, induction motor. So let me shift it. So now this is my 12 volts battery. Remember, remember it's still on 20 amp this here because you can see the sign. You can see the sign here. This sign here means AC current. You can see it's like a wave. So that's why if you check here, you saw the sentence. This is for volt. You can see like a wave. So it is AC. Where this is like a direct, it is straight. So now you can see the. So now you can leave it at the same spot. There's no changing. All you have to do to shift it here. You can see this 0.20 is white. It is white. So now this is for DC to measure DC current. So now this is the terminal. This is the output terminal. So now let me measure with this 36 volts motor. Let me measure with this 36 volt motor now. So what am I going to do now? This is my the terminal. So all you have to do is to connect the one terminal of the motor to the battery, one terminal of the motor to the battery. Then let me one terminal of the connect the one terminal of the emitter to the motor, then one terminal to the battery. Then let me check. Okay. Okay. So what this motor is consuming on 12 volts is 0.6 amp, 0.62 amp. So when you do the mass, you will have about 7 watt plus, almost 8 watts. So that's what the motor consuming. So let me do the test again. You can see when you put your put your hand, it will be like a load. You have not added a load, so the current will rise up. But on idle, is 0.62 amp. So you can see, you can check all those things, not only checking for voltage, you can also check all those things with, assuming you don't have a discount meter. So this current meter is very costly somehow. So assuming you don't have this current meter, you can use here for checking the DC. Note, don't put it, don't put it, yeah, just check it and disconnect it immediately, because you can see 10 seconds maximum. So you don't have to put it at long, so because it will affect the this meter. It doesn't, it's not used for just for plus test. When you test it and you have the result, you disconnect it immediately. Likewise, this one you can leave it there. You can leave it there. So, and remember, it is 20 amp maximum. So anything that draw more than 20 amp, it will damage this meter. So it will affect the IC inside. So it won't give you accurate data. So when you want to check for voltage, you have to connect here, then put here. So this is for voltage. So this is for voltage. Let me measure the DC, this battery. You can see 12.68. So another thing I want to demonstrate, another thing I want to demonstrate is that you can use this to measure capacitor value. You can use this to measure the capacitor value. So like I was saying, you can use this to check, let me show. You can use this to lead capacitor. You can use this meter to check the value of the capacitor, because sometimes they will put a label and they just write 35 or thereabout, but when in the actual sense, the value of the capacitor won't be up to that. Okay, like this one now, it is rated at 5 UF. This is about 15. You can see it here, just scratch it. Maybe it's 15 UF. Why normally this is you can see 24. You can see it here, 24 UF, 24 UF. Okay, now, what if you want to check the value of the capacitor? You want to check the value of capacitor, then pull this terminal out, put it here. You can put it here, you can put it here, anyone, because you have to check this line. So you can put it here, then put this one, put it at common. Okay, so now let's measure. This capacitor is 35 UF. Okay, let's check if it is up to that. Okay, now you can see when you put this terminal together, there's no any signal. See, there's no any signal. So when you put this terminal together, there's no any signal. So now, okay, let me put it as the terminal, at two terminal. Oh, sorry, I put it on volt, still on the volt. So you have to switch it to 200. See. So now you can see I put the terminal together. There's no, so now let me put it here. So which means that this capacitor is up to the value. You can see it's up to the value. It's up to the value. You can see it. Just it's up to the value. I think the meter is disconnected. So you can see, I don't know, it just flattened, but it shows that this capacitor is up to the value. It shows that this capacitor is up to the value, almost more than. So now let's check this now. This one is the is 15 UF. You can see it here. Okay, let's check. Okay, it is accurate. Though this meter is or it's accurate. Okay, now this one, the 24 UF, I see here 24 UF. Now let's check if it is up to the value. It's not even close to 24. Why we are displaying 13 UF. So you can see, okay, such capacitor, you believe it is 24 UF, but in reality, it is not up to. 13 point. So, which means this capacitor, and in terms of weight, this capacitor is more weight than, very heavy than this capacitor. This one is 15 UF, this one is 24 UF. But in these two capacitor now, if you put it on the same generator, this one will give more voltage than this one. So forget about what they wrote here. It doesn't tally the reality. So they just put, you can see here, 13 UF. Why it show 24 UF here? So but this one is a 15 UF, 15 UF. So 15 UF. So this one 35 UF. So which is, these two capacitor is equal to the task. Why this one is just a fake label. So my channel, I teach a lot of things, so which indicate that you can use your meter to check current, DC current, AC current, volts. You can use it to check the capacitor value. Here is to check diodes. I mean, yeah, this is the ohms. So there's a lot of uh, data here where data here you can use this meter to check. And once you are doing, just make sure that you follow the instruction, because any mistake can affect this meter memory, and by doing that it won't give you the accurate data again. So this is that is it. So I hope you have learned a lot, which means you can use this meter to do the mathematics, assuming this parameter is not available. Thank you for watching.